Hi everyone and welcome to the first video on the entity relationship model. So in this we learn firstly what is the entity relationship model. We learn the difference between entity sets and entities, which are a very important part obviously of the ER model. We learn about attributes and the different types of attributes, and we learn about relationship sets, which is the R part of the ER model, links or relationships, and cardinalities. So let's get started. So the ER model was invented in 1976, and this was 5 years after the relational model was invented, which is the popular table model that we all use on computer systems nowadays. So the ER model does not have tables or columns. Instead, it has these rich diagrammatic constructs like boxes, diamonds, and so on. And because it has these rich constructs, it is a great way to capture the meaning in the data requirements that would be normally given in a natural language like English. So it's a great intermediate step between looking at the requirements in a natural language and coming up with a design of the tables. So there's no one correct ER diagram because all we are doing is we are interpreting the English language or some other natural language meaning of the data requirement. So there's no one correct ER diagram. However, there's appropriate ways of using the different constructs and inappropriate ways. So let's take a look at some of the constructs now. So the first and arguably the most important part of the ER model is the entity set and entities. That's the E part. So an entity set is a box, shown as a box, that contains a bunch of, it could be objects, it could be people, it could be events, it could be anything that we want to capture data on, such that what's common about all the elements in a box? Each element or thing in the box, also called an entity. Remember, an entity could be an object or a people or an event, not a person, is described by the same set of properties or attributes. So if I have, let's say, a box called sales, this is going to have the sales events in the box. Each sale is an entity in the box and is described by the sale ID, the sale date, and the sale amount. So these are the three attributes or properties that we're going to use, let's say, to describe each sale in the box. Now, each sale in the box is going to have maybe different values for these attributes, but they're all described by these attributes. So normally when we write the attributes next to the box, we only list the intrinsic properties of each entity next to the box. And we underline the primary key, which is the usually the property that has a unique value for each entity in the box. So here is the diagrammatic construct, the entity set, sales, that is shown here as a box. You can see the intrinsic attributes of a sale that we want to capture. Now the intrinsic attributes will be based on the description, so it's possible we may want to capture many more attributes related to each sale. But in this simple example, we're only going to look at three attributes: the sale ID, the sale date, and the sale amount. Now obviously we also want to capture other information about a sale, which we would call linked properties. For example, which customers took part in the sale, which employees took part in the sale, what items were actually sold. Now these are not intrinsic properties of a sale, so they are shown as relationships, which we'll see later. But for now, it's important to note that we only list the intrinsic attributes next to the box. So let's say that we want to capture a linked property of sales, which is basically the customers who took part in the sale. So the way we show that is shown in the diagram here. And you can see that you have a box called sales, and then you have another box called customers. All the customers are in that box, described by their intrinsic attributes. These are the intrinsic attributes of sales. And now we see a diamond in the middle, which is the relationship set. And here we are calling it customers in sale, or customer in sale, sorry. We want to make sure that all the diamonds and all the boxes have unique names in our diagram. So here the customer in sale is a set of links. So basically a diamond is a set of links, just like an entity set is a set of objects or people or events. A diamond is nothing but a set of links between entities. So the set of links between all customers and all sales transactions is shown in the diamond, called customer in sale. Each link in the diamond, so the diamond consists of many different links that I'm showing here. Each link in the diamond is we need a way to identify each link. So each link is going to go from one sale to one customer. So each link is going to be identified by two endpoints, the sale ID value and the customer ID value. So here it might be, let's say, S1, and here it might be C1. So S1 and C1. We cannot have duplicate links in the diamond, so we cannot have two links going from the same sale, let's say, to the same customer. They have to be, at least one of the endpoints has to be different. Okay, so the first thing we note is that we have these links that are going between the boxes, one entity on each side, and the endpoint identifiers of each link are implied, and they should not be shown as attributes of the diamond. So here we are not going to show the sale ID and the customer ID as attributes of the diamond. The fact that we have a diamond is enough to show that it's a set of links and that they have their endpoints as the primary key values. If we had a three-way diamond, there would be three boxes involved, or actually you could have two links going from the same box, but you would have three links going out of the diamond, and there will be three endpoints, and so on. We never ever repeat any attributes in any diagram. So if you find yourself writing the sale ID in more than one place, then you're doing something wrong. We don't need to show the sale ID here as an attribute of customer in sale, because the fact that we have a diamond there automatically implies that each link is identified by the sale ID and the customer ID taken together. However, we may want to capture more information than merely a link between a customer and a sale. So for example, for each sale, we want to of course link it to the customer, but we also want to give it a rating by the customer. So if we want to give a sale a rating by a customer, we don't want it to be an attribute of customer because a customer could be involved in many sales. We don't want it to be an attribute of sale because it's possible that a sale may have many customers and each one is going to give it a separate rating. So what we do is that we make it an attribute of the link between a sale and a customer. And this is the extra information that we want to capture in each link. So in this case, there'll be three things that will identify a link. There'll be there'll be two things that will identify the link, which will be the ID values, and there'll be one extra value for the attribute that will further describe the link. So here is some sample data that would be contained within the boxes and the diamonds. Now it's important to note we don't show this data. We just show the overall sketch that shows everything in plural, the entity sets, the relationship sets, and so on. And we don't really know how many sales we have, but I've just shown some sample data here for us to have an idea of what would be contained. So in the sales box, we have two entities shown as an example here. There's sale S1 and sale S2. In the customers box, there's two customers, customer C1 and customer C2. You can see that each customer has values for each of the attributes, and each sale has values for each of the attributes. For the customer in sale, which is the most interesting thing here, you'll notice that there's three links that are out there. There's a link between customer C1 and sale S1 with a rating of 10. So notice that the identifiers are going to be C1 and S1. Then there's a link between C2 and S1. So there's two customers linked to S1 here, and C2 gave it a rating of 9. And then there's another link between C1 and S2 with a rating of 8. So there's 3 links that are going out in the diamond between sales and customers, and the 3 values are given here, or the data in each link is given here. Okay, let's talk about the types of attributes we have now. So up to now we've seen the simple single valued attributes where there is a single value for each entity or link. So if there's one customer, they'll have one value for the name, or they'll have one value for their address. And it's also non-divisible. In other words, the string that is used to store the address is not divisible. But you can also specify an attribute to be composite. In other words, it can have subparts. So for example, the address might be broken up into the street address, the city and the state, and so on. Also, you can specify an attribute to be multi-valued, which means that for a particular customer or a particular sale, there may be multiple values for that attribute. So an example might be, let's say, the phone number of a customer. If you want to store 3 or 4 phone numbers, then you could make it multi-valued. And of course, you can also have an attribute that is both multi-valued and composite, so that, for example, let's say you want to store multiple addresses for a customer, and each address has composite parts, then you can have multiple values that are composite. Let's see an example. So here we have an entity set called customers, and we have the first is the primary key, of course, which is always single valued and simple. But then we have the customer name, which is a composite attribute, and you see that with the 3 lines here that are that you can see these 3 lines. So the customer name has 3 parts, subparts: the first name, the middle initial, and the last name. So the diagrammatic construct for a composite is this tree structure that you see. And you can have a branching tree structure too, so you could have stuff broken up further if you wanted. This, of course, would be the root of the tree, and these would be the nodes, and then what is at the end of the tree would be the leaves. For a multi-valued attribute, you can see that we use a double ellipse. So customer email out here is shown as a multi-valued attribute, and this means that for a particular customer in the box, we will store multiple values of the email. So they could have any number of emails that we store. It's not limited to 2 or 3, but any number of emails. It's not a good idea to have email 1, email 2, and email 3 as separate fields, because many customers may only have one email, so we are wasting space. And what if a customer has more than one email, or more than 3 emails? Then we would need to be able to store that too. So having a multi-valued attribute is the most flexible way to specify that we want multiple values stored of that attribute for a particular entity. Finally, we come to what is often a confusing part of relationships, which is cardinality. So here you can see cardinality written as a minimum and a maximum value. In some cases, they only write the maximum value. So out here, you can see that if this is written as a maximum value, there would be n on this side and m on the other. And it would be what is popularly called a many-many relationship. But we would like to use a more precise notation where we write the minimum and the maximum. So let's see what this means. So on this side, when we read it, we are trying to interpret it as follows. We are saying for each entity on the other side, for each customer, what is the minimum number of sales and what is the maximum number of sales. So here it's 0 sales and maximum n sales for each customer. When I'm trying to interpret this cardinality here, what I'm saying is for each on the other side, so for each sale, what is the minimum number of customers and what is the maximum number of customers. So always remember, you go for each on the other side, what is the minimum number here of customers, what is the maximum. So this way we can write the minimum and the maximum. So this is like a superset of all the systems out there. Okay, so we see that the ER model is a rich semantic data model. It has a lot of constructs. We've touched on many of them. We'll look at a couple more in the next video, but we've touched on quite a few of them. And these different constructs, if used appropriately, allow us to capture the subtleties of meaning of natural language data requirements. So as a fun activity, you can try to draw an ER diagram of a university. It's a pretty well understood application. It's also called a domain, where course sections are offered of different courses. For example, let's say there's many course sections of the database course. Students take these course sections and get a grade for them, and professors teach these course sections and get an evaluation for them. And it's important when you do the relationship sets not to forget the cardinalities.